The preparation of singlet oxygen. Attention! In this experiment, hazardous compounds are handled and large amounts of chlorine and hydrogen chloride are released. Working in a fume hood or outside is mandatory. I don't take any responsibility for damage done to persons or property caused by the replication of these experiments. For the experiment, a gas generator was set up with a 3-necked round-bottom flask and a pressure-equalizing dropping funnel. Alternatively, a gas bottle of chlorine could be used. This was connected to 3 gas washing flasks with a fritted disc. In the first one, the main reaction will be taking place. The second one was filled with 15% sodium hydroxide solution to neutralize residual chlorine and hydrogen chloride. The last one was filled with activated charcoal to remove residual traces of the gases. Later on it will turn out that the whole apparatus leaked, even though it was checked for leaks before. Next, the dropping funnel was removed and 35 grams of trichloroisocyanuric acid or TCCA were added to the flask. For the main reaction, 2 solutions were cooled in the fridge, 50 ml each of a 20% sodium hydroxide solution and 12% hydrogen peroxide. When mixing the two, heat is produced, which increases the decomposition of the peroxide. This is prevented by the cooling. Next, only a part of the solution was added to the first gas washing flask because its exact volume was unknown. That's why the flask to the right was filled a bit too high with 100 ml, but it was not a huge problem. The increased decomposition of the peroxide became visible immediately. Then it was made sure that the stopcock was closed, otherwise large amounts of chlorine would be formed rapidly. To the dropping funnel, 38 ml of concentrated hydrochloric acid were added. It reacts with the TCCA on contact to form chlorine and isocyanuric acid. Then more of the residual peroxide solution was added to the first gas washing flask and the stopcock was opened very slowly. At first the air in the apparatus was replaced by the chlorine and forced through the gas washing flasks. After that came the chlorine as it could be seen in the dark. When the chlorine hits the alkaline peroxide solution, a red glow can be observed. The stronger the gas flow is, the brighter it glows. When chlorine reacts with an alkaline solution, a disproportionation reaction takes place, in which hypochlorite and chloride are formed. The hypochlorite reacts with the peroxide to form chlorine peroxide, which is unstable. When the chlorine peroxide decomposes, oxygen and chloride are formed. In simple terms, the oxygen molecules are in a highly energetic unstable state at first, which is called singlet state. That's why it's also called singlet oxygen. When the oxygen falls back into the ground state, which is called triplet state, the energy difference is emitted in the form of light. The wavelength or color of the light depends on the energy difference between both states. This way of doing the reaction is very impressive, but due to working with chlorine it is also more dangerous and way more laborious. An easy alternative is preparing a solution made of 20 ml of 12% hydrogen peroxide and 0.5 grams of sodium hydroxide. When the TCCA is added directly to the solution, the same reaction takes place, although less impressive. The effect is easily visible to the naked eye and the amount of free chlorine gas is very low. The addition of a sodium hypochlorite solution instead of the TCCA would also work. This was the preparation of singlet oxygen. I hope you enjoyed. Please rate and comment. If you want to know more about the theory behind this experiment, you can watch my video here, or you can watch another video about oxygen here. A big thanks to my supporters on Patreon.